Chapter 19. Properties of a magnetic field. Dear students, tell me, in which direction does a freely suspended magnet settle? North sound. Correct. And what are the names given to the two ends of the magnet? North pole, south pole. So magnets are made from alloys of iron, cobalt and nickel. Nippermag, an alloy of iron, nickel, aluminium and titanium, is used to make magnets. We know that alnico is a magnetic alloy of aluminium, nickel and cobalt. So now we'll see about magnetism. Place a steel bar AB on a table and take a bar magnet. Place its north pole on the A end of the steel bar and drag it towards the B end. Lift the bar magnet and drag its end pole from the end A to the end B of the steel bar again. Repeat this 15 to 20 times. Now take the steel bar near some iron fillings and observe. The steel bar will be seen to have developed magnetism. This method of magnetism is called the single touch method. The magnetism created by this method is of low strength and lasts for a short time. Now, another method. Place a steel bar on a table. Take two bar magnets. Place two opposite poles of the two bar magnets at the center of the steel bar. Drag these poles apart, one to the A end of the steel bar and the other to the B end. Repeat this 15 to 20 times. Now take the steel bar near the iron fillings and observe. This method of magnetization is called double touch method. The magnetism generated by this method lasts longer compared to that generated by the single touch method. Now about Earth, which is a gigantic magnet. The scientist William Gilbert gave a round shape to a naturally occurring magnetic rock. He suspended this spherical magnet so that it could turn freely and brought the north pole of a bar magnet near it. The south pole of the magnetic sphere was attracted towards it. And this is the scientific explanation why a freely suspended magnet always settles in the north-south direction only. The north pole of a freely suspended magnet settles in the direction of the geographic north pole of the Earth. It means that the south pole of some gigantic magnet must be near the geographic north pole of the Earth and the north pole of that magnet near the geographic south pole of the Earth. Gilbert informed that the Earth itself is a gigantic magnet. However, the south pole of this magnet must be near the geographic north pole of the Earth, while the magnetic north pole is near the geographic south pole. Now, magnetic needle. Take a square cardboard and mark the directions on it. Place a pot filled with water at the center of the cardboard. Take a magnetized needle and stick it to a small piece of cardboard by means of a sticking tape. Place the piece of cardboard with the needle on the surface of water in the pot. Now tell me, in which direction does the magnetized needle point? North. Correct. Let's see about magnetic field. The British researcher Michael Faraday named the lines going from one end of the bar magnet to the other as magnetic lines of force. The region around a magnet where the magnetic force acts on an object is called a magnetic field. The magnetic field around a magnet can be shown by means of magnetic lines of force. The intensity of the magnetic field at a place can be gauged by the number of lines of force that pass through a unit area at that place perpendicular to that area. Michael Faraday imagined that there might be invisible lines of force going from one pole of a magnet to the other, and that magnetic attraction or repulsion might be taking place through the medium of these lines of force. If Faraday's idea is accepted, The intensity of the magnetic field can be obtained from the number of lines of force. The intensity of a magnetic field is low where the lines of force are sparse, and the intensity is high where the lines of force are concentrated. Now, properties of magnetic lines of force. The magnetic lines of force are imaginary connecting lines. The magnetic lines of force always run from the North Pole to the South Pole. Magnetic lines of force are in a state of tension like a straight spring. The magnetic lines of force repel each other. The magnetic lines of force do not intersect each other. The number of magnetic lines force at a particular point determines the strength of the magnetic field there. Now, penetrating ability of the magnetic field. Spread some pins on a table and hold a cardboard at a small distance above these pins. Place a bar magnet on the cardboard and observe. The pins get attracted towards the cardboard. Now, increase the layers of cardboard and repeat the procedure. We see that the magnetic field can pass through a cardboard. However, by increasing the layers, the intensity of the magnetic field is found to decrease. Now, metal detectors. The function of these machines is based on electromagnets. Metal detectors are used in very important places like an airport, bus station, certain temples and buildings. They are used for inspection of persons entering these places. Metal detectors are used to detect very precious articles and also in food processing industry to detect any iron or steel objects mixed unknowingly in foodstuffs, as this would be harmful to health. In geology, the machines are used to detect the presence and quantity of metals.